All right, welcome everyone to another edition of the Subseasonal Forecast Contest. It's my name is David Margolin. It's September 22nd, so we're still forecasting CDDs. I know some folks have already started to shift fully ahead into winter, but we're shifting forecasting CDDs for this week and one more week, and then officially we'll switch over to HDDs as we turn the page into October. We have a very special guest today, Carl Schreck. Carl's Dr. Schreck is an expert in ENSO and MJO research and has done a lot of applied research too. So it's going to be great to have Carl to talk about how we can use the MJO and ENSO in our forecast process. And we'll turn it over to Carl here in just a second. In terms of today's agenda, though, I propose a kind of a similar path. We'll start with attribution. We'll look at last week's forecast. We'll talk about the summer, which is coming to a close. Or is today the first day of fall?
It is.
It is. Okay, so officially coming to a close. And then we'll get into the forecast. And again, that's where we'll spend a lot of time with Carl to talk about MJO and all that good stuff, tropical forcing signals in general. Other than that, I know sometimes there's sort of hot topics. Are there any other sort of items that folks want to make sure we cover today? Special hurricane, anything like that? Okay. All right. So if you think of anything, of course, just jump in. This is pretty informal. All right. So before we get, like I said, before we get into today's forecast, we'll go back in time and to the most recent verification. And I believe, no, that's one before this. So let's go one before this. If anyone can't see my screen, let me know. There we go. All right. That's right. Okay. So the most recent verification or forecast and verification was forecast from September 1st out to September 16th to 20th. And this wasn't a great one, but there's a couple of things going on here. One is sort of the limitation of our skill metric here, the continuous rank probability score, but also the fact that it was a tough forecast. The verification came in a lot colder than I think most of us expected. So the verification here is at the bottom. Again, this is CDDs. So it came in at 22.5 CDDs, which is the reason I accentuate that is because we haven't had a lot of, there's a couple of reasons, but that may be basis normal. That may be the coolest forecast of the season, or at least that we've looked at. Certainly one of the coolest forecasts of the season. To just put in perspective, the 10-year was at 33, or is at 33.9, and the 30-year, the official 30-year is 26.8. So this came in colder by a decent margin, colder than the 30-year normal. And so let's just look at that map so you guys can see the map. I was cheating on this earlier, looking at this. It was, kind of your classic, at least from a temperature pattern. And we're going to go back and look at the scores here in a second, but just look at this. It was more of a classic kind of ridge trough, or, warm in the west, cool in the east. Of course, we've had a lot of the fires and dry and hot weather in the west, of course. And look at this trough in the east. And I guess, I think this is really interesting too. I know we talked about it a little bit last week, but, I think this is, when we put our industry hats on, and I think Dave D'Arcangelo's on and some other folks, is really interesting to me too, because it really shows you that, weather is, the old cliche, it's difficult to predict, right? It's hard to predict, but flippable coin kind of thing. But, September historically is supposed to be one of the most reliably warm months. I think there's some statistics to back this up, low sample size, but like looking at the last 10 years, the trend, blah, blah, blah. I remember talking to some of our vendor folks. I don't remember specifically which ones, but, earlier this summer, middle summer, and we were talking about September a little bit, and, they were saying some of the same things. Like, yeah, we feel pretty good about September. And this is, this is a really interesting September, because not only is it not super hot, like following some of the recent trend, but, we've had some really actually cool periods here. And so, we'll open it up to discussion on that in a minute, but it was a challenging forecast in that. Oh, sorry, I'm on the wrong page. It was challenging in that light. The fact that it came in so much cooler, and just let's see, looking at the human and non-human forecast here. Again, the verification we said was at 22.5. And what was our range of forecast? Persistence, obviously some of these persistence inputs, not a good forecast, right? These are just generic forecast, persistence inputs based on, how anomalous the periods, 5, 10, 15 days, whatever, before it was. So persistence obviously would have been a great failure. And looking at the model forecast, the CFS, believe it or not, the CFS, you could argue was a broken clock kind of situation, but whatever the case, the CFS certainly was a cool forecast, actually even cooler than the verification. The ECMWF here, where's the ECMWF, was 27.7. So out of all the forecasts here, it did pretty well. And then, obviously some of the human forecasts here, myself included, I was in the 30s, right? So, and just to put it in perspective, that may not look that bad, but remember here, I'm bashing my own forecast, but the standard deviations, or the spreads we call them here, have also are coming down now that CDDs. So the spread on some of these forecasts, like my spread was 7, like a 1 standard deviation spread. So I was much further. It was my errors were probably closer to 2 standard deviations, so at least 1.5 standard deviation. So I wasn't even within a standard deviation, of the right forecast. So one other great thing here too, and then I want to open it up. I believe this is the first forecast where we can look at the maps. So we can actually see how the maps looked versus verification. So let's do it. ECMWF. Yeah, I'm glad we have this. The ECMWF. And by the way, the dates sometimes don't line up perfectly, so just keep that in mind. That's not an error. It's the best we have. First impression, pretty good in terms of the pattern. And then let's look at the CFS. Well, yeah, again, maybe it's the broken clock adage, but not too bad. Let's flip over. Where's the verification? Where did I put that? Over here? Yeah, so I'll put it over here so we can kind of toggle. There's the CFS, there's the EC, and there's the actual verification. Let's do one other thing here. I want to look at the upper air pattern. We also have the upper air, and I want to, sometimes it's the right for the wrong reason kind of thing, right? Let's see if it's that game or if it's, I'm going to do the globe. Yeah, let's do the globe. All right, 500 millibar coming up. All right, there's your 500 millibar pattern. All right, now let's do the same thing here. So I'm going to pull up the EC. Let me get rid of the temperature, just make it a little easier on us. All right, EC. It's global, right? Yeah, so let's do that. And then let's get the CFS global. All right, then let's just toggle a little bit. All right, so there's verification. Make sure the dates are right. Yeah, they're approximately right. There's the EC. There's CFS. CFS, wow. Again, you maybe argue it was wrong, right for the, I don't know. But I guess you can't argue with results, one of those deals. Anyway, let me stop there. Because I don't want to hog all this time, and is an interesting forecast. So does anyone have, you can see what we have here. You look at the model forecast, the dynamic model forecast. I'll give it this is Dave's subjective view, but I don't know if it's an A, but if it's not an A, it's pretty good, right? Certainly better than a lot of the human forecasts and some of these other inputs. The forecast in general was a pretty big surprise to the cold side from a lot of us, myself in particular. Does anyone have any just general thoughts on this forecast in terms of, there's a couple different angles from it, from the industry perspective, like, again, how much of a surprise? And I know maybe it didn't have, Dave talked about this a little bit, like the market impact. Okay, it had a market impact, and everyone's looking at winter. But again, like, does anyone have any thoughts, I guess, even if it's outside the market, like what drove this September to be so different than recent Septembers? I'm really curious about that. Maybe Carl, maybe you have some thoughts in terms of tropical forcing signals. Anyone else kind of look at this thing and have some ideas in terms of what happened? And I don't know, does it mean anything going forward?
Uh, not to brag here, but can you take a look at my forecast? I don't remember what I said.
Yeah, let's look at Philip. This is Philip on the line. Yep.
Okay, since I was just looking, I put a minus zero point 0.5 CDD fudge factor, so I must have seen something that suggested a cooler risk, but I don't remember what it was.
Yeah, this is a good point. Philip, other than this is Maxar. So other than Maxar, which has been doing this for a few more years than Philip, Philip did have the best for human forecast. So let's read a little bit more into what Philip was saying. That's a really good point. See if we can learn something. So what was your fudge factor? This is the Philip strategy statement. I know it's a little bit small, so if we can blow that up, you guys should be able to access it too. Um,
Looks like the CPC was forecasting cold anomalies in the eastern third of the US that may have been a factor. And then, the models, I think, let's see, the CFS I said had a weaker ridge and a trough digging into the northeast US. That sounds familiar. And I'm not sure what I saw uh, for concern for. I just wrote decrease my forecasts given
oh,
concerns for core
yeah.
verification, but I'm not too sure.
Well, here's one thing you said. Here's one thing, and there could be something defensible or maybe even objectively defensible about this, but we'd have to look. As we approach the end of the cooling season, I started weighting the 10-year mean a little less. You know, we talked about how during the core of the summer, the 10-year trend, whatever you want to call it, climate change factor, seems to be stronger than in the winter. So that was probably a good hedge there, Philip, doing that. You switched to the 15-year and the 20-year, which decreased your number a little bit. You also, well, this was more of an uncertainty thing you put in, Philip. I don't know if it changed your mean value, but you did address the fact that there were multiple type tropical cyclones. I believe, who was it last week who talked about this? I can't remember. Maybe it was Dave Darkangelo, actually, who talked about the fact that maybe it was the tropical cyclones that kind of got things out of whack a little bit this September, that we saw, you know, a recurving typhoon or so that kind of shifted the pattern away from, you know, maybe a warmer kind of theme. Anyone else have anything? I don't know if anyone's talking. If you might be on mute. Anyone's talking or just quiet. Okay. I mean, again, some of these numbers, and this is just the limitation of the CRPS. The fact that the verification was relatively close to the normal, and our CRPS is benchmarked to normal, so that's why you get some of these inflated scores. So it's, in some respects, it's not as bad as it really is, but that's, you know, that's the scoring system at the moment. All right, you guys want to you want to shift gears here to the current forecast then? Let's do that. All right, so again, today's the 22nd, so we're still forecasting CDDs. Um, this is the board at the moment. I'll just give a quick look at the board. See if I can, there we go. So it looks like the range for today's forecast, the persistence numbers are still pretty warm, the long-term persistence, right? Because the summer in general was still on the hotter side of normal, for sure. So up in the 20s, if you include those persistence factors, and then actually the 5-day persistence factor, as you would expect, is actually pretty cold. So the persistence factors really range depending whether you're going to go on the long-term persistence or short-term. But anyway, we've got a range here from about 9 CDDs on the cold side to up close to 25. The 30-year normal is 12-ish, and the 10-year normal, what was it, 15? I looked at this earlier. Where am I? Yeah, about 15 and a half or so. Um, all right. Yeah, Carl, if you like, if you feel comfortable, we can kind of turn it over to you here. If you want the screen, that's fine too. And I think, again, you don't have to go into the specifics about the forecast per se, but I think it would be interesting just your experience in terms of how you look at the MGO in terms of kind of thinking about, 2 to 4 week forecast or even month ahead forecast. And also anything you want to add. I know it's an interesting ENSO. People are paying attention to the developing La Nina. Certainly, if you have any thoughts there in terms of what folks might be interested or should be looking at, that'd be great.
All right, sounds good. Yeah, if you can let me share screen. There we go.
That's
All right,
nice.
can you guys see it?
Yes.
All right. So I'll kind of start, just kind of go through my typical forecast process. So it'll be a little bit over the place, but start off with where we're at right now. Can see the remnants of, you can see Tropical Storm Beta down on the Texas coast. Teddy spinning around up towards the Canadian Maritimes. When I saw the satellite image this morning, I had a little PTSD thinking back to Sandy 8 years ago. Looks a little bit similar, but not nearly as intense and not going the same direction, thankfully. But other main feature you can see is there's a pretty good ridge over the US right now, over the central US. We're still a little bit in the trough associated with that's feeding into the dry sector of Teddy as well there. So that's what's been giving us the cooler temperatures here on the East Coast. And kind of, I think one of the main climate drivers right now is this trough over the Gulf of Alaska that's been feeding a positive EPO that I think is a big part of our current weather pattern. So kind of next thing I would do is take a look at Alicia Bentley's site to kind of look at the synoptic dynamic picture that we just saw. And so you can see that big trough in the Gulf of Alaska in the PV. So this is a little bit of a funky diagram if you're not familiar with it. The contours are tropospheric, or PV near the tropopause. The green and yellow and red shading is precipitable water to give you an idea of how much moisture is out there, and the blue shading is the jet stream. And the vectors are divergent winds. And so you can see the tropical storm beta, tropical storm beta there in the Gulf Coast with lots of moisture there. Obviously, lots of moisture with Teddy as well. Otherwise, fairly dry, and can kind of see this big ridge over the central U.S. and the trough along the East Coast moving out to sea now. Next thing I like to take a look at is the 5-day outlook from the Hurricane Center, which is a lot quieter than it has been. We'll talk a little bit more about why that is in just a second. But really nothing to concern ourselves with. I haven't taken a look at this invest here yet in the near Florida, but 10% in 5 days, that doesn't sound like much to worry about. So beta is probably going to stay ashore, so it's not going to intensify much. Teddy is only a problem for Canadians, and Paulette could wander back in the tropics, but it's probably just fading out to sea. So moving on to kind of my home turf, looking at the large-scale tropical patterns. So I use my website, nkix.org/MJO. And usually the main thing that I'll look at here are Hoffmullers of velocity potential. And this is just a really, I find this is the quickest and easiest way to track both the MJO and various equatorial waves as well. So the shading green colors are essentially enhanced upward motion. Brown colors are downward motion, and the contours identify different waves. the MJO in black moving eastward slowly down towards the right. Kelvin waves in blue go a bit faster. Equatorial Rossby waves moving westward a little bit slower. And then the other key feature is the low frequency in the magenta lines. And so, key features, the MJO has been moderately active for the last couple months. It was a pretty good MJO in July and August that was associated with a ton of tropical cyclone activity across the Pacific and into the Atlantic as well, including Laura and Marco that we had a while back. Then it circled back over to the Eastern Hemisphere and kind of stalled, got lost a little bit. There was some signal of it that sped forward with maybe some Kelvin wave characteristics. And to a degree, this is part of what, so in terms of tropical cyclone activity for the Atlantic, there's kind of two things that you want to see. One is enhanced convection, the green shading or the solid contours. But really more important than that is reduced vertical shear, because really the Atlantic is a shear limited basin. And so really what you want to, if you want to have a tropical cyclone, you really want to have wet to your east and dry to your west, because that's going to have upper level easterlies that's going to counteract the climatological westerly shear. And so that's why you tend to have enhanced activity in the wake of an MJO going through, as long as it's not so dry that it cuts things off. And so that's part of why the first couple weeks of September were so active, was because the MJO was really parked here over Africa and the Indian Ocean. So the outflow from that going westward created easterly shear that again counteracted that climatological westerly shear and helped enhance the tropical cyclone activity. As we see, that's now kind of shifted a bit, where the MJO has moved more towards the maritime continent, where it kind of got stuck for a little while. But there is at least a Kelvin signal moving it, pushing it back to the east towards the Pacific. So I would expect things in the Atlantic to remain quiet for at least the next week or so, maybe 2 weeks, until you get back into the enhanced phase of the MJO. Because while if there's dry to your east and wet to your west, then you actually have enhanced westerly shear, and that's going to really make things even more difficult for TCs. Not that you can't have one finding a seam somewhere, but it's just not going to be as favorable. It kind of counteracts the La Nina background that we've had. And that's one thing to point out is, interestingly, the La Nina doesn't show as strongly on this map. A lot of times you don't always see it in velocity potential, the ENSO signals, but usually there would be more of a signal here. And for La Nina, you would expect wet around the maritime continent and dry over the Eastern Pacific, which you are seeing. Interestingly, if we shift this to OLR, a lot of the La Nina signal has really been focused more on the Indian Ocean this year. So you see this nice, strong, enhanced signal around 60 east for the Indian Ocean. Typically for La Nina, it would be a little bit further west, more towards 120 east. So that in theory was probably even more favorable for the tropical cyclone activity that we've had, even though we've had a ton of named storms, but not much actual activity to go along with it. So looking more at the actual MJO index, this is also from my page on the RMM tab. And so you can click on total to see the actual RMM index. the MJO was pretty active from an RMM standpoint from August and into the first half of, for most of September. But it's recently gotten kind of caught up here in phase 5. And at least from an RMM standpoint, it's really stood still in that region in the maritime continent. And a lot of times, a lot of folks will stop there, but I like to try to figure out what is the RMM thinking, like what's going into that stationary pattern. So I'll take a look at the individual components of the index, because the RMM index, and I apologize, hopefully you guys have some familiarity with it. But the RMM index is a combination of OLR, U850, and U200 from 15 south to 15 north. And so in the upper left here is the total index that averages them all together. And then the other 3 panels are one variable at a time. And what you can see is that the U200 is really strongly contributing to that phase 5 stationary signal, where some of the other variables are noisy as well, but U200 is really what's pushing it into that phase 5 being amplified. Those are a little bit noisy, so I also have them on here with an MJO filter that smooths it out a little bit. And again, you can see that of the variables, where the star is for today, U200 is the one that's got kind of the strongest signal right now, although none of them are particularly strong. So if we go back to the Hofmullers and take a look at what's going on with U200, what we see is there's a really strong westerly wind event at upper levels around 120 west. And this is something that I've noticed a lot of times will create a particularly strong MJO index, whether or not it's really the MJO. It seems like a lot of times there'll be like an extratropical signal that's creating enhanced upper level westerlies in the Eastern Pacific. That seems to be a popular place for them to occur. And so like if you look back in late July, August, there was a nice propagating westerlies followed by a nice propagating easterlies. You're not really seeing that this time. This is much more of a stationary signal. There is some westward moving Kelvin component to it, but it's a much more stationary signal, which again kind of tells me that it's probably something other than a real MJO event. So that's why really I would look at the, well, let's take a look at low levels real quick too. Just you can see at low levels there was a nice westerly wind event back in August, but it's been more easterly since then, consistent with the stronger, developing La Nina event that we have now. But you can see that there's not really nearly as much of a signal to speak of at low levels. So going back to the upper level velocity potential, right now, kind of the center of, well, actually, let's look at it on a map. That's probably going to be a little bit easier to understand. So here is, on the left column is the last 4 weeks of velocity potential, and on the right column are the next 4 weeks in the CFS forecast. And so you can see there was a decent propagating signal for the last several weeks. It's somewhere between the maritime continent and the Pacific right now. These are 7-day averages, so it's kind of in between. And the model does tend to have this signal moving forward off to the east. So this signal kind of over the Central Pacific would be more of like a probably phase 6-7 type of pattern. And then as you get into week 2 or week 3, it gets back over the Atlantic Ocean. So that's more of like phase 1, probably looking at like phase 6-7 for this coming week, phase 8 next week, phase 1 the following week, and phase 2 going into the middle of October. And so again, if we think about it in terms of what the tropical cyclone activity would be interested in, right now it's dry. That's not great for things. As that convection moves into the eastern Pacific, that's going to be enhancing the westerly shear. So again, that's not really particularly good for tropical cyclone activity. So it's really more when you get into around October 6th and into the middle of October that you might see the tropical cyclone activity pick back up again. So I certainly I expect the next couple of weeks to be quiet, but I certainly wouldn't rule out a significant storm in the middle of October. And so take a quick look at the various models from CPC's MJO website. The GFS, they have two options for a lot of these models, where it's either the raw model output or the bias corrected. It's not entirely clear to me why you would pick one over the other. It seems like bias corrected would usually be the way to go, but it's a linear bias correction, so maybe it's not always adjusting properly. But with either of these, the GFS is just showing some really slow eastward propagation, a lot slower than what I was describing with velocity potential. CFS is even more stationary, really kind of stuck in that phase 5 region. ESMWF shows a small turn, but is also fairly stationary. So these are probably, again, really keying in on that westerly wind event and not so much what would actually be going on. Let me pull up one other page real quick while we're talking MJO. So this is one of the pages I like to go to for the composites. This is Steve Baxter's page at CPC. And the nice thing, he's got all the different seasons. I wish the interface was flipped a little bit. You have to pick your phase and then you can pick your season. I mean, I think you know what season you're in, then the phase is a little bit more uncertain. So it'd be nice to mouse over that instead, but that's neither here nor there. So if we look at ASO or SON, probably SON is probably a more representative of what we're going into right now. So if we've got phase 5, you can either look at it masked for significant composites or unmasked. And this is essentially every 5 days going forward. So assuming that we're in phase 5 right now, what would we expect? And you tend to see a warm signal, especially for the southern plains, and maybe a developing cold signal for the northern plains. You can also look at it in terms of 200 millibar winds to try to get the full Rossby wave train. And it's kind of indicates that over the next couple weeks, you're going to start having this wave train developing from the Western Pacific, creating more of a ridge pattern in the Gulf of Alaska, trough on the West Coast, and then another ridge. So that's probably more of a PNA negative signal that it would be moving towards. Yeah, especially as you get into the third pentad, so about 2 weeks, or 2 to 3 weeks out. So shifting back to mid-latitudes, so we were talking about the upper level circulation. I like Alicia's page because you can go back and forth in time a little bit more easily. and you can see how these patterns have evolved. But going forward to today, we've got that trough in the Gulf of Alaska, kind of a big ridge over the US, except for the trough associated with Beta, and then that trough off the East Coast associated with Teddy. And kind of as we go through, that trough from the Gulf of Alaska breaks off and tries to move over to the East Coast sometime next week, possibly giving us another shot of cold air here in the East Coast. And this, trough ridge trough pattern from the Gulf of Alaska to the East Coast towards the end of the GFS forecast here. Looking at some of the other teleconnection patterns from Ryan Maui's weather models page, looking at ECMWF forecast, we've got a fairly positive AO right now, but that's forecast to diminish pretty quickly here. The EPO is positive and expected to remain so till essentially the end of the month. So that's something that I would kind of lean on as a potential predictor in a forecast. NAO is a little bit weaker, but also positive. PNA is jumping back and forth, but certainly increasingly positive right now before taking a little bit of a break. And WPO is also going to be positive for a little bit. Can kind of see similar patterns in the ensemble, where again, EPO is going to be positive at least kind of through the end of the month. And the ensemble has generally a positive PNA for most of the forecast period. And if we take a quick look at the long range ECMWF forecast, it shows kind of the EPO going more negative towards the first week of October, and then becoming more neutral. So you may expect a kind of a reverse pattern of what we're seeing right now from this model. But PNA is generally going to be more positive for the next couple of weeks. And so finally, looking at this with maps of the 500 millibar height anomalies from the ECMWF ensemble. Again, we're seeing that trough and the trough in the Gulf of Alaska, the ridge. We're again going to see that trough kind of move eastward towards the start of next week. Trough ridge trough for most of the remainder of the forecast period in that model. Also take a quick look at the 5-day running averages from the 46-day ECMWF. So again, starting off with trough in the Gulf of Alaska, ridge over the US, and pretty quickly switching to this trough ridge trough. And then towards the middle of October, maybe the ridge gets a little bit more pronounced, but that may be the model responding to the general warming trend more than anything else. So those were kind of the main things I was going to show. Let me show one other thing real quick. Let me see how to zoom. There we go. So this is a figure from a paper by Emily Riddle from a few years back, showing how different phases of MJO affect different probability of different signs of different teleconnections. And so, like I said, we're kind of in a phase 5 right now, which tends to favor PNA negative in the short term, but more of a PNA positive as you go out a couple weeks. And as you go into phase 6, 7, 8, 1, you see that positive PNA get closer and closer as you get further out in the MJO cycle. Similarly, as you get into phase 6 or 7, it tends to favor a negative AO pattern later on in the subsequent weeks. So there's a couple of things that I would tend to look at. And I think that's most of what I was going to show. So I'm happy to open it up to questions now or any feedback.
All right, thanks, Carl. Hey, Carl, do you mind continuing to share your screen just because I would imagine there could be some questions.
Sure.
Any questions for Carl? There's a lot of good stuff here, I know. I definitely have some questions, but I want to see if some of our students or other folks want to ask Carl. Who wants to be first? Philip, I know you must have a question.
Well, I guess the only thing I was wondering is, looking at the MJO signal, since it looks like the RM index has a sort of stuck in phase 5, but that doesn't exactly look like that's the true evolution. So would you say that using the lag composites of phase 6, where if you combine the velocity potentials and the other things, would that be a more accurate depiction of what the MJO signal is doing?
Yeah, that's a great thought. Yeah, and again, that's why I always complain about this interface, because like I don't want to mouse over the months, I want to mouse over the phases. But yeah, so instead of, I think kind of what you're saying is like instead of, two sides of it. One is that, well, we're right now in phase 5 technically, but maybe we're really more phase 6 or 7. And so, maybe that's where you want to start from. And then kind of the other side of that is you can also, this is useful for getting out the evolution, but you can go ahead and skip ahead to, phase 8, because that's probably where you're going to be closer to the verification window. And so maybe using one of the shorter lags instead. I know Steve Baxter found that a lot of times the signals are stronger at lags 2 to 3, and these are pentads, so it's around 15 to 20 days. So yeah, that's a good point.
Reminds me too, before the end, we've been working on a new MJO kind of tool. I'll show it to you. It's on our website. It'd be good to get your feedback.
Cool.
Well, while folks are thinking, I had a question. Carl, if you go back, this is great seeing all this stuff, by the way. I just wish we had another hour. But could you go back to the one where you showed that it was like your last slide, the PNA, the AO, and the MJO, and you were talking about like the lag response or something or other. Yeah, exactly. Carl, I was just going to ask you, like, is it also fair to say, I know that, the MJO and some of these teleconnections, like, they're not completely independent, like, from each other, such that, looking at, it could be helpful, there could be more helpful research studies, or perhaps I know you've done some of this, but to look at these hand in hand. In other words, if someone is looking, it's winter and they're thinking, what's the risk of a really strong negative AO? It's not just looking at, okay, let me look at this left chart. Is the MJO moving into phase 1 or phase 2? It's also, what's the extratropical background state, or maybe even the ENSO background state? And it maybe some of this is intuitive in the sense that, well, if the AO is already super negative and the MJO moves into, I don't know, phase 1, or I guess it would be like, 15 days later, is the AO going to be negative? Maybe that's sort of intuitive, but it could also be right that maybe it's not even the AO that you want to look at. Like maybe when because the PNA is obviously more related to Pacific, or directly, explicitly, related to extratropics across the Pacific. And if the PNA is lined up a certain way, if the background state of the PNA is a certain way, then the MJO comes through phase 1 and 2. it may give you more information, sort of like a constructive, deconstructive interference in terms of whether that AO is really going to go off the charts or not 15 or 20 days later. Can you talk around that research or your thoughts on that?
Yeah, yeah, that's a great point, and you know, you're kind of alluding to, you know, we had a paper a few years back looking at specifically the PNA and how, you know, different phases of the, you know, the initial PNA phase has a big impact on what the MJO's temperature pattern impacts are going to be further down the line. And it's more than, it's a nonlinear response. It's more than you would get just from averaging a PNA composite and an MJO composite. And there, as far as I know, there hasn't been a ton of research on that since then. And I think it's primarily a lack of a sample size issue, where if you start slicing and dicing the data too many times, you start to, you know, just run out of cases to examine. You know, this is something we're looking at. Some of the climate models might be helpful, where you get thousands of years of simulations. But that's one of the other things I did want to point out. I forgot to mention. So, you know, one of the two of the coolest things I've learned in my career about the MJO. First was basically what Dave taught me, that the MJO is not just some academic thing that only you know, folks at universities are tracking, but that, you know, energy traders are tracking as well. That blew my mind. But then my mind was blown again a couple of years ago when CPC started working on their week 3-4 forecasts for the US. And their number one predictor that they use is what they call the MLR. It's a multilinear regression model, and it has 3 predictors. And so the climate change trend and the MJO.
Wow.
Nothing extratropical in there.
Wow.
Nothing
dynamic?
What's that?
No dynamic guidance?
Yeah, exactly. I mean, they look at the dynamic guidance, but it's not, apparently not as good as just using those 3.
Wow.
And for everyone to change our formula statements.
Yeah, exactly.
No, that's awesome. That is great to know. Wow.
I know they're working now on introducing a stratospheric component into it.
Wow.
But from what I understand, that's kind of a forecast of opportunity, as you can imagine, like when there's a sudden stratospheric event.
The only thing we don't have explicitly in our forecast contest would be the ENSO component. We do have some climate trends predictors. We do have an MJO input signal. It's very basic, sort of analog, you know, based on the current state. But anyway, I mean, it's not to say it's exactly the same. You know, it isn't. But that's really interesting to hear that that's what they do. That tells you something about the science of medium, you know, subseasonal forecasting for sure.
Right.
And you know, I think another thing, you know, I know we have a few more minutes here. I think Philip was kind of alluding to this a little bit, or at least in part, the fact that you know, we have some great tools, analog tools and composites to look at the, you know, relationship if the MJ is here, phase 5, whatever. But, and again, maybe in part this is a sample size thing, but regardless, you know, when you start to look at whether the MJO is progressive or not, like is it moving in a relatively, you know, let's just say we can categorize it. It's moving progressively versus it's kind of stalled. I think when you know, just based on my experience, and maybe Carl, you could talk about this too, right? The expected impact, the historical impact, it can be significantly different. So knowing that, you know, not just knowing that information about whether you think it's going to be moving from phase 5 to 6 to 7, you know, in 10 days versus, you know, there's a high likelihood that it's going to stall in phase 5. That can be an important determinant also in terms of how you apply the MJO impact. Is that fair to say, Carl? Is there anything else you want to say?
Yeah, no, that's a great point too. that I know that there's been a little bit of work on, kind of does the atmosphere care about the duration, or how sensitive is it to the duration or propagation of the signal versus just where is there, enhanced momentum going into the jet stream. And I know a few folks have played around with one of the things that the RMM does is it subtracts out a 120-day running mean to try to take out the ENSO signal. And there's been some playing around with why don't we just leave that in there and get kind of a combined index. And that's something that I'm interested in playing around with as well. But I think there is, the location of the convection matters, but yeah, I'm sure there certainly is a component that's associated with that propagation as well. So yeah, that would be a cool thing to kind of break it down into fast versus slow MJOs and try to see how different is it.
All right, one last question on my end, since climate change came up. And I know these aren't necessarily easy answers or things necessarily that you've even studied, but what do you know? What is there a study looking at how MJOs, either the frequency, the intensity, just similar to hurricanes, how MJOs may change or are changing, the characteristics of them now and in the future as a function of climate change? And when I put my industry hat on, really what I want to know is, could it be that, I don't know, because it's changing in a certain way, that it could set up more sustained cold patterns in the United States, even though everyone else is hot. It could set up these different, recurring regimes because of the way the SSTs or oceans are changing. I don't know. Do you have any thoughts on that? Have you seen much research in that area?
I know I've seen folks working on it a bit. I don't know off the top of my head what the consensus is. But kind of going back to our earlier discussion, I would strongly suspect that in terms of like US impacts, it would be much more of how is the mid-latitude wave guide changing, and then how is that being affected by the MJO, regardless of whether you can even consider the MJO today as it was 50 years ago or whatever. I think it's probably more these changes in the jet stream that are climate related that would probably be the bigger factor in that. The other thing I'm sure you're aware of, there's been a lot of exciting research in the last couple of years about the role of the QBO in modulating the MJO's extratropical impacts. And I'm not sure how well that's understood yet, but that's certainly something to consider as well. And I always get the phases backwards, but I think it's that the MJO is stronger and has more impacts during the easterly phase than the westerly phase of the QBO. Could be backwards, but something along those lines, where one phase of the QBO you get a stronger convection and a stronger extratropical impact than in the other phase.
Actually, I lied. Just a part B to my question that's really helpful. Putting aside the climate change, I know there's been work, and I don't know where it's at, but I know there's been some studies, and I know meteorologists like me sometimes talk out of our what, in terms of the relationship between MJO season, is the word interannual, like year to year MJO variability as a function of SSTs. Put aside whether the oceans are warming or cooling, just how much of the if I look back at we look at this winter, and it turns out that there's going to be 5 of these massive MJO events, or 3 this winter. How much, or versus this year is going to be like one of these years where there's not much. How much of that has research tied to SSTs? Like if the global, if the Indian Ocean's really warm, anomalously warm this year, watch out, we're going to have big MJO events, versus if it's cool. Can you talk around that at all?
That's kind of the main talking point that I've gotten on that, is that the MJO is strongest when ENSO is transitioning. So when you're going between La Nina and El Nino or vice versa, where when you're in the peak of one or the other, it tends to be weaker. But I'm not sure how robust that relationship is. But yeah, I mean, that certainly would be a very interesting question, because that's the other thing that folks don't really recognize enough, is that the MJO is both very episodic, that there's times when it's really strong and really there, and there's other times where it's not there at all. But on the flip side of it is there'll be times where, from an RMM perspective, there's nothing there, but you can still definitely find something if you know where to look in the Hofmullers, like right now.
Yeah.
So it's kind of a two-pronged problem of, how do you figure out how often the MJO is really strong, and then how do you identify it when it's a little bit more in the gray.
Great. Well, I know we're kind of out of time here. Any quick last questions for Carl before we let him go? No? Because this is great. I mean, I feel like a lot of great information, Carl. And I think also a lot of what you help shed light on is this is still an area of research where there's a lot of opportunity, right? So for our young, for our students out there and stuff like that who are interested in this, I mean, there's a lot here, right? So there's still a lot to be learned, and also the insight about how CPC, the inputs to their subseasonal forecast. I mean, that was really great too, and that also just tells you how much more work needs to be done before we can, really figure things out, so to speak. So.
Yeah.
So yeah, thank you so much for being here, Carl. Hopefully we can have you back again soon, maybe sometime this winter or something like that.
Sounds good. Happy to do it.
All right. Well, thanks to everyone else here for participating, and we'll see you guys again next week. Bye, guys.
Thank you.
Bye.